Okay, and welcome back, everyone. And so let's just get right back to this problem. So remember, we are trying to find the area of the shaded space. So that's kind of this weird shape here in the middle. And what I was trying to show you before we broke, before the video obviously had to complete, was that what this shape actually is one big rectangle with us subtracting like four like quarters of a circle from each corner, right? And so if we can figure out the entire rectangle and then subtract away those little quarter circles, we are going to be left with that kind of weird shaded shape in the middle. Now, the issue is we don't have all of the dimensions that we need yet. And real quick, just to recap it back into the last video, remember I had this line here, but the problem was, right, rectangles are base times height. We do know the height is 6, but this 6 on this side only goes from here to here. So we don't quite have the full base. And so we need to figure out, and I'll kind of jump to the chase here, the radius of a circle, right? Because basically what's happening is, if I clear up this whole thing, I can pretend kind of like this corner here, and I shouldn't pretend, it's the truth. That's like the center of our circle, right? That's like the center of our circle. And so if I draw a line to the edge of the circle, that's my radius. And radiuses are always the same. So those two are both a radius. And these two are both a radius. And these two are both a radius. And these two are both a radius. So we need to figure out the radius of our circle. What it's going to help us do is complete our entire rectangle, which is huge, but then it'll also allow us to work with finding the area of those quarter circles so we can eventually subtract them away, right? Now, here's what we need to see. See this 2? That's just this little space right here. And so that's just this little space as well. But somehow we have to link that 2 to this 6. So the whole thing is 6 on a side, and obviously it's a rectangle, so right side and left side are the same. So the whole thing over here is 6 as well. If this middle section is 2, we need to figure out what the radius of a circle is. Now I want to give you a hint. This r and this r, we're going to assume they're the same. And so the radius is going to be the same all the way around. And so the question is, if this part is 2, what do these other 2 radius sections have to be to make it 6 in total? But the radiuses have to be the same, and what they have to be actually is 2 as well, right? Because if this bottom part is 2, and the middle part is 2, and the top part is 2, then the whole thing is 2 plus 2 plus 2, which is 6, right? And so all of these little places where I've put an R, they are 2 units. And that's crucial because now we can kind of complete the rectangle, right? All of these R's are 2. And so this entire bottom part, which we'll call the base, is 2 plus 6 plus 2, which is 10. So now I can find the area of my rectangle. The area of my rectangle is going to be base times height. My base I just found to be 10. My height was always given to me on the side, which is 6. And so the area of the full rectangle is 60. Now remember, that's not what we want. We're going to have to subtract away these little corners. So now let's start talking about circles. Now, the only thing I want to say to you is this. We have 4 quarter circles. And I need you to pay a real attention here because we're going to kind of skip a step. We have 4 quarter circles. So 4 1/4 circles. If I have 4 1/4 circles, that means I have 1 full circle, right? Because 4 quarters equals 1 total thing. And so really all I'm going to do here is I'm going to do the area of 1 circle. Because when I do the area of 1 full circle, that's going to be what all 4 of these corners are combined. And then we'll just subtract away that 1 full circle. And so the area of a full circle is pi r squared. And we just figured out that the radius of all these circles is 2. And so the area of the full circle is pi times 2 squared. And so we want to type pi times 2 squared into our calculator. And so I'll do that. Second pi, parentheses 2, and then squared. And that tells us 12.6. Now, I want to repeat what I just did there. 12.6, right? There isn't a full circle that you can see in this problem, but there are 4 quarter circles. 4 quarter circles. And 4 quarters equals 1 whole. And since they're all the same radiuses, we can just act like it's 1 whole circle, find the area for that whole circle, and that's what we are going to subtract away now. And so our total will be that 60 from the rectangle minus the 12.6 from our circle. And when we go back to our calculator, we will do 60 and then minus, and I'm going to highlight the 12.6, hit enter, and we get that it's 47.4. So this is going to equal 47.4 and then inches squared. Excellent. Now, that's a tricky problem. Definitely a tricky problem. So, yeah, but I hope that makes sense. Now, two more. All right. In this next one, I think this is a little bit easier to see. We are going to assume, so this is definitely a circle. We need to find the area of the circle. And then we'll assume that the white shape in the middle is a square. All right. And so to find the area of the circle, we need pi r squared. So we need the radius. To me, this is a diameter. It's going through the center, touching the edges of the circle. And so I'm going to assume that the diameter is 16. And so our radius is going to be 8, right? And so the area of our circle will be pi times 8 squared. So let's plug that in real quick. Pi times 8 squared is 201.1, we'll say. 201.1. Now, to find the square, we're going to use kind of a different area formula than we use a lot of times. Now, it's in our note packet, and so if you look back at part 2, you will see this, so it's not a big problem, but I want to utilize it now. In our note packet, we said the area of the square can be diagonal 1 times diagonal 2 divided by 2. And this diagonal right here, it is the diameter of our circle, but it's also the diameter of the square, right? And it's 16. And so if I draw a second one in there, that's the other diagonal of a square. And in a square, the diagonals are the same. So that one's 16 as well. Both diagonals are 16. And so the area of our square is going to be 16 times 16 divided by 2. And when we do 16 times 16 divided by 2, we are going to get 128. And so since the square is white and the circle is shaded, we will do, for our total, the shaded piece, which is 201.1, and we will subtract the white square, which is 128. And when we do 201.1 minus 128, we are going to get 73.1. And the units are feet squared. Perfect. So I think this one probably makes a lot of sense. Just be really clear about us using the diagonal version of the square area, right? All right, last one. We got about 5 minutes left, and I think we can fit it in. Obviously, this one is relatively complicated as well. So here are the shapes we're looking at. I see a base, I see a height of this outside four-sided shape. They are the same number. Because they're the same number, our big four-sided shape that's shaded on the outside, that is a square. And so let's just find the area of it real quick. And this time we won't use the diagonal one. Area of our square we'll just call base times height. And so that's 32 times 30. Ooh, that's terrible. 32 times 32. And 32 times 32 equals 1,024. So perfect. That is the area of everything, right? But we need to subtract away 1, 2, 3, 4, 5, 6, 7, 8. There's 8 more after that. So we need to subtract away 16 circles. Now, for us to subtract away 16 circles, we need to know the area of like one of the circles, and then we can multiply it by 16. One note here is we are going to assume all of the circles are the same, okay? All of the circles are the same. Now, we can prove it, but I think it's just a little bit easier just to, think about, I think they're all the same, right? So here's what I want you to see. See how this line is 32 centimeters? What if I drew that line in the middle of all 4 of these circles? It is still 32 centimeter distance, but now it's just drawn as diameters of 4 different circles, right? And so if I do 32 divided by 4, and 32 divided by 4 is 8, that's going to tell me that the diameter of one circle is 8. Now, diameter is all of it, right? And area of a circle is pi r squared. So we need the radius. But this 8 is the diameter of a circle because I know that from side to side here, the total is 32. All 4 circles are the same. So if I divide it by 4, it's going to tell me the diameter for each one, right? And 8 plus 8 is 16, plus 8 is 24, plus another 8 is 32. So it still maintains the fact that, the total length is 32. Now, that's the diameter. For our formula, we need the radius. Remember, radius is half of a diameter, and so our radius will be 4. And so let's plug that into our circle equation. Pi times 4 squared. And that's going to equal, and let's just type it in, pi times 4 squared, right? So second pi times 4 squared. And so the area of one circle is 50.3. 50.3. But we don't have one circle. Again, that is the area of like one circle. But we have 16 circles. So for 16 circles, we need to do 16 times the area of one circle that we just got. So 50.3. So when we go back to our calculator, we have our 50.3 sitting there. If we just hit times 16, now it'll take that area and it'll make it the area of 16 circles. So all 16 circles take up 804.2. So 804.2, right? And now that's the number we want to work with. And the reason is our whole square area, the whole thing, right, is 1024, but we want to take away the 16 individual circles. So now we have to subtract 804.2. So our total will be 1024 minus 804.2. And so if we go to our calculator and do 1024 minus and go up and highlight that 804, hit enter again, it's going to tell us 219.8. So our total will be 219.8. And this time we'll throw the units on, centimeters squared, and that is the whole thing. And so that is the idea here for part 5, which is actually the last part of this unit. So we are going to combine everything we know about finding areas of 2D shapes, and we are going to combine those shapes. So sometimes, like in problem number 1, we need to add some things together. Other times, if we have white space in the middle of shaded space, we're going to have to subtract away those other areas. And that's the whole idea of part 5 here. Taking everything we've learned so far and just combining shapes or taking away shapes as well. And so go ahead and work on the part 5 worksheet. We'll obviously have a part 5 review tomorrow. And as always, ask questions if you have them. And thank you so much for your efforts. Have a great day.